Pause the video and take a second to read this problem to make sure that you see all the details mentioned within it. You are asked here to find or told some things about perimeter and asked to make some conditions about area of the rectangle anyway, and then asked to find the dimensions of the rectangle, the length and the width. So I've just redrawn that field shape here. And the perimeter, of course, is going to be all the way around this figure. Think about it like this, kind of like the laps that you would take around the track within this figure. And we need to have a formula for that, for perimeter, just based on these dimensions, length and width. And we also need to write a formula for area of just the rectangle based on length and width. And then we're going to rewrite the formula for perimeter in only one of those terms, either length or width, not both. Started that process here for perimeter. We obviously know we need these two segments for perimeter. L and L is going to give us 2L. And then we're going to need to find this distance around these circular pieces, or half circle, semicircle pieces. And there's going to be two of them, so I already started with 2. And then to get the distance here, or perimeter around one of them, I really need to be thinking about circumference. So half, because it's just one of these things, of 2 pi times r. 2 pi r is the circumference of a circle. And in this case, the r is based on the width. And it's half of the width, which would be w divided by 2. Now you might think, oh, I didn't need to do quite all that because I see this as just one full circle if I attach them end to end, and that's true too, and you could have skipped a little bit of a step right there as well. So simplifying some things within this formula and substituting the value for the perimeter that we're given, we have the following equation that we can write to relate the length and width of this figure to the perimeter, the given perimeter. So we know as well that the area is mentioned here, the area of the rectangle, and area of a rectangle is just length times width. But because area is what you want to maximize, then we need to rewrite the area in only one of these terms, not both length and width, but only one of them. So to do that, we'll take the previous formula and solve for just one of these terms, either length or width, and substitute it into the area formula. So here I've taken that previous formula with perimeter and solved for L, and I get that L can be rewritten as this expression, 1200 minus pi w over 2. So now I'm going to replace L in the area formula with that expression. So again, where there was L in the area formula, I've replaced it with its equivalent expression. Now I can turn to a graphing calculator or Desmos, and I want to graph this equation and look for the point that is the maximum. So I'm going to use Desmos for this. Give me a second to pull up that screen. So here in Desmos, I am graphing that equation that I just mentioned, except for instead of A, I'm using y, and instead of w, I'm using x, just for the purpose of graphing. And I can start to zoom out because I know that these are going to be very large values, and I'm looking for a maximum, so I can either click and drag or continue to zoom out, try to find that maximum value. And it's slowly coming up here. All right, so here it is. There's the maximum value. Don't forget, though, your input value is W, and the output value here is area. So then with the precision that's asked for, we have that W is 190.99. I could then come back and use one of the other formulas like this one and substitute W's value to solve for the other dimension, length. And in this case, length then, with that same precision, is 300, and that's our final answer.